my name is Mark Kirby. I am your teacher's nephew.
Okay, and so where did you start practicing front flips?
I started practicing front flips on my trampoline, which is just outside. I was way too close to the edge of the trampoline and landed directly on my head. My head went like this.
So have you tried to do a big bounce forward flip on the trampoline since then?
Oh yeah, I do them all the time. Yeah, but we're not really talking about the knee flip. We're talking about the no bounce flip.
You're right. When you stay towards the center of your trampoline, you have less injuries.
Yes.
What do you think was important for you to improve on? Is it getting more air going up, or is it getting more sort of like torque?
I think I'm good with this. I think I need more tuck. I need a tighter tuck.
A tighter tuck.
More air.
More air.
And maybe a mat.
And a mat. Using a tool strategically. I love that. What are your next steps to achieving the front flip on the grass?
Going back to the trampoline, practicing getting height on air, and then doing the same thing on the ground, and keep doing the flips on the trampoline.
What do your instincts say to you, that moment right before you're about to go into your tuck? What are your instincts saying?
They tell me to turn, do it quick, and oh, God, don't fail.
Thank you, Mark. I hope you have a great rest of your day.
You too.
Thanks, Mark, for letting us know how your journey to learning the front flip on hard ground is going. So a trampoline is often a circle. So Mark was saying that if he was closer to the center of the circle, he was more likely to get a safer landing, right? And that the further he went off to the side was more dangerous. A vertical jump up keeps you in the center of the circle. Whereas if you are moving horizontally, right, and you can think of horizontal because the horizon that the sun rises and sets, if you've ever seen a sunrise on a beach, that horizon line where the water meets the sky, that goes from left to right, and so you can think horizontal that way. So then also we talked a little bit about degrees. So Mark said that he's landed on his head before, and that would be a 180-degree flip, which is good if you're jumping into a pool, but if you're landing on grass or a trampoline, not so good. The first time Mark tried a front flip on his grass, he landed on his back, and he exclaimed, "That's a 270-degree rotation." So if standing straight up is 0 degrees, landing on your head is 180 degrees, landing on your back is 270 degrees, and landing back on your feet is 360 degrees. So in this case, 0 degrees and 360 degrees represent being on your feet for a front flip. What does that tell you? What does that tell you about degrees? How does that relate to a clock? So here we've seen two instances where we can relate to a circle. We can relate to actually the shape of the trampoline, or we can think about the degrees of a circle in terms of rotation, and we know that 0 degrees of a circle is just a straight line. There's no angle there. And then you can open up to a 90-degree angle or a right angle. This is the corner kind of angle that you see in squares and rectangles and lots of corners of your house. 180 degrees forms a straight line. So we have 90 degrees like a corner, and then 180 degrees forms a straight line. Now we're talking about 270 degrees. So 270 degrees looks like a 90-degree angle if you're looking at the smaller side. But if you think about this as a reflex angle is an angle that's greater than 180 degrees and less than 360. So a reflex angle here, this is 270 degrees, and then the full swipe of the whole circle takes us back to 0 at 360 degrees. All of these short lines that I overlaid with green, those are the radii. So a radius is the distance between the center and any point on a circle. The distance around the circle is called the circumference. So we have the radius, and then we have the circumference. The circumference of a circle is kind of like perimeter, the distance around the outside. One last part of the circle before I go is the diameter. the diameter is the distance from one point on a circle to the center of the circle and through to another point on the circle. That distance is the diameter. And did you know that the diameter for any circle fits into the circumference about 3 times? There's a little bit left over. It's a little bit more than 3. It's like 3 and 10% of the diameter, or 3 and 14% of the diameter. You can just say 3. So I would say about 3 of the diameters fit into the circumference. That ratio is called pi. Pi is a Greek letter that we have assigned to the ratio of the circumference divided by the diameter. And what that tells us is that for any circle, the diameter of the circle, where do I have a circle? I have one right here. So let me just draw on this. I hope it comes off. The diameter of a circle wraps around the circumference of the circle 3 times, and then 15%. So let's see, how could I estimate 15% using the circle? Well, the center is 50%, the radius is 50% of the diameter. Okay, and then, so I don't want 50%. A fifth of 50 is 10. So if I broke this into 5 equal parts, so I find the middle line, that's 25% of the diameter. So then I want 20%. So I'm just going to nudge myself a little bit to the right and left of the 25%, and I'm going to estimate that that's about 20% of the diameter. So I need 3 diameters and about 20% of the diameter to be able to create something that could wrap around the outside of the circle. Thanks again, Mark, for inspiring us with your front flip to learn a little bit more about the vocabulary of a circle. You showed us how circles are in your life with your trampoline and your front flip thinking about degrees. I'm so proud of you. I'm so proud of you all for tuning in. Stick with your intuition. Listen to your instincts. Stay tuned for more Muddy Math videos, and I'll see you next time here on Muddy Math.